Good afternoon. It's almost over, huh? Think there is one more after this?
Yep.
Great. Let's get it over with. And thank you for coming. You know, I know spreadsheets doesn't sound very exciting. I'll try to make the best out of it. So just for a brief history of spreadsheets, they actually started a long time ago. They were not they were not UI based. They basically write a set of equations. So in a way, we're functional languages. And then you will process this through the computer. There was Lambda and Autoplan. People pay good money for those software. Then someday, Mr. Ricklin was the name, invented VisiCalc, and the Cambrian explosion of the spreadsheet started. VisiCalc actually was very pitiful as an interpreter. It required the user to keep hitting recompute until finding the fixed point of the spreadsheet. You know what I mean? It was not doing the analysis of the dependencies and computing it the first time. SuperCalc did that. When you don't know, you guys are way too young to know. I actually heard of VisiCalc, Quattro Pro, Lotus, and Excel. Which ones of these are alive today? That's what I thought, Excel. I just found out this week, preparing for the presentation, Quattro Pro is still alive. Although I don't think it has much market share. So the great extinction was basically Microsoft killed everybody. And now we are in the cloud era. And, you know, it's been 38 years since VisiCalc. I mean, and you think about it, spreadsheets are actually kind of a functional paradigm. Because if you look at it from a statics perspective, on a worksheet, like you have a set of formulas. Let's assume that the entire model fits in one worksheet, because for purpose of analysis, is the same, formally speaking, right? Normally, you have many worksheets in a large workbook, but let's say everything is together in one. You just have a set of formulas that refer to other variables in the same worksheet, and hopefully, it's a directed acyclic graph of computation, so it doesn't go into into circular references, and it's stateless. It just compute, right? So Peyton Jones was very well known here. Basically, was the first I saw publishing that say this is basically a system of equations, like a functional language, only that is a first order functional language, right? And he said, you know, basically, if you consider the language of Excel formulas a programming language, which it is, it's actually the programming language most used in the world. And that's even considering that over half people who use spreadsheets just use it as a repository of data. Okay? Even counting those out, just it's amazing the amount of people who do computation with spreadsheets. If you think, why are they so successful? Because I don't know your experience, but the first time I was across a spreadsheet, I think actually was a multiplan or something. He said, oh, you just put here, you write the formula, click on the cell, and you just get done. So the level of the learning curve to get started is very low. Okay, the problem is what happens later. They're visually and intuitive, and as I said, they're functional, they're reactive. What you do with the spreadsheet, you change a cell, and then things change. And that's where it's not like I defer, but in the analysis that went into the product that I'm going to show today, I hope to do the demo, what we take very much into account is the fact that it's not purely functional. There is an element imperative there, and it's with the user. The user assigns values to cells. Those are the inputs. He wants to change it, but everything else after that is just reactive. I don't know if you know, but spreadsheets actually, spreadsheets are considered the reason that the IBM PC took over the market. The people, people basically asked to put the guy of Lotus, Mitch Kapor. IBM asked him, do the Lotus 1, 2, 3 for the PC first. Okay, because at the time there were a lot of other computers based on other processors. And that became popular in business. So the PC actually took off. Beginning was like a personal market, but very quickly what really created the growth was that all offices around the world started adopting it, and largely was because of the spreadsheets. And decades later, they're still, I would say, one of the most used productivity tool in the world. It doesn't go away. If you were to compute the value of Microsoft Excel alone as a company, if it were spun off, would be worth in the billions of dollars. When there was the cloud revolution, I was wondering, because I always thought that spreadsheets were showing their age, and I was not alone. Paul Graham thought the same thing. Say, maybe this is the moment of disruption, because now people have an incentive with another platform. Don't have to be exactly the same. People use only a fraction of the functionality of Excel, and I focus on Excel because they have the lion's share of the market. It didn't happen. The funny thing is that it's so prevalent and people are afraid to change it. And I was at Google at the time, pushing some of my crazy ideas, and saying, no, we just want to be like Excel. Same thing at Bloomberg, by the way, I built the calculation engine that powers the Bloomberg terminal. Well, at least starting in 2008 for several years. Now they are in, that product has evolved. But at the time, they were doing all this code in C++ on the client. The market ticks were coming, and then they were doing the recomputation and trying to keep things in sync. And I noticed, because I always wanted to work in programming languages and not do boring work, say, what they need is a spreadsheet engine, because it's like a reactive model. That was in 2004. And they laugh at me. In 2005, they laugh at me. In 2006, one guy was way smarter than I am. He worked at the show. He got it. And he say, okay, let's do it. It became incredibly successful. Because now people who specify a lot of those screens that change in real time with a set of formulas, kind of like at the times of Autoplan, right? The computation model, I call that. So it was like the model of the spreadsheet. And then they map it to the UI the way they want it. So the cloud did not change it. At Bloomberg, we clearly try to do things that work exactly like Excel. I implemented, besides the engine, I had to implement like 140 formulas to kind of basically clone what Excel was doing. That was actually a titanic amount of work, and I got people to help me with about 20% of those. And but at Google, the same thing. Everybody wants to be just like Excel. So everybody will be like Excel, but the underlying design, I'm going to argue, is not a good one. Now, I'm going to skip these slides very quickly because it's a litany of people complaining about spreadsheets, different reasons. You can read this. Some have to deal with the fact of the security. This thing is not on the server. It cannot be secure, etc. It's one of the dimensions. But what came out of my analysis is these people are looking at the symptoms. What's the core cause of all this drama? Why, like say, they're inflexible here when I need to rearrange it. Well, there are many problems. One, the data abstraction sucks. Imagine I come to you and I say, I invented a great language. The simplicity, it's amazing. There is only one type of data structure, and it's the bidimensional array of dynamically typed variable, kind of JavaScript. Unitype, right? Bidimensional array of variables. Those are the only objects that you can create and name. Think about a worksheet. When you start a spreadsheet document, you cannot really name the cells. You can create aliases. I'm going to show you, maybe not, because I don't want to take more time. The aliases are a poor substitute for having real variable that you give it a name. The only things you can name are the worksheets. They're bidimensional arrays, and then all the formulas you write is like basically writing, imagine you are constrained to program inside arrays, writing formulas, referring to the coordinates of other things, which makes it completely illegible, okay? Somebody thinks that the aliases can alleviate this problem. I have prepared, but it takes like 5 minutes. 2 typical errors that happens when people do aliases because they don't work the way people think they work, okay? So I'm going to skip that. Then for people who are kind of a bit more advanced, and me, not so much, sometimes people are marketing, as in people creating worksheets where they want to define they have data from the market and they want to see the product fit along certain dimensions with the customer preferences. So they define their own Cartesian distance for it. That's not there. It actually would be pretty easy to write it, okay? And people don't even need to really know much about Lambda functions. You just take it like many of the people I know, they are actually quite quantitatively inclined. They will be able to write a function with arguments and specify the formulas. You cannot do that, okay? Of course, somebody says, not true, look. You can define formulas, you go to the VBA. Yes, but you broke paradigm. You went to this world of VBA, an imperative model. And by the way, the API sucks. I don't know if this the interpreter I have here is actually slower than Excel. Excel has progressed over the year. Of course, Microsoft knows well about compilers. They actually do compilation under the hood, okay? The spreadsheet is incredibly fast. But if you go VBA, for instance, do a very stupid just time loop, computing a spreadsheet many times to do a Monte Carlo simulation, we beat them 3 to 5x factor, which is amazing because it's such a bottleneck, that API, okay? So VBA, by the way, also force people, now they need to become real programmer. Well, these are in people, particularly in finance, the analysts, the people working in the insurance, the people who, who work like, again, in the financial industry particularly, they're very quantitatively inclined. They're used to use Excel. They just want to write formulas. If you look at the typical thing we look in programming languages, the expressive power really is very poor there. Okay, and this is not orthogonal at all. It just forces you into those bidimensional arrays and program with coordinates. The one thing they do have is the conceptual simplicity. You can learn Excel pretty quickly, right? So this is what I was telling you, because I don't like to read the slides. I can go at it. I call it the programming by coordinates. I haven't heard people refer like that. Also the A1 soup. I wouldn't be surprised if other people talk that way. A1 is the name of the standard coordinate convention. Microsoft had the RN, CN, row number, column number, but people got used to the Lotus, so the A1 won. Okay? So they're hard to read, understand, and validate, and they're very easily broken. Because only first order functions are supported, you get proliferation of functions. You want to sum a range, but say, when I want to sum only those that fit a certain criteria. You want to pass the criteria as a parameter, but you can't, because it has to be a function, right? So no worries, sum if. I want to count it. Okay, count if, so you can do that. And I used to have in this slide, what if you want an average if? I found out 3 days ago they actually added it. So people have been asking for this. All you need, it's high order functions that you can pass the criteria as an argument, and you have all the ifs you want embedded in operating with the ranges. Cannot do that. So you can create, not only VBA, I actually did you can create it in C++, all over there, fast, DLL, and need to interface it. This is even more, the impedance there, you need to go to programmers that are intermediate to advanced to do the proper way and interface it with Excel. All this fact, imagine how painful will it be if it were not for the fact that you, largely when you enter formulas in Excel, you just point and click to the cells. It helps you doing the editing, it even paints the graph of the cells you're referring to. Now you're gone, comes the guy from outside, and what does he have, or she, to work with? The coordinate soup, okay? If you're really good, like my friend Peter in the financial industry, if you're really good, you actually exploit the only thing that you can name, the worksheet. Peter once, he showed me a lot of, when I did the MBA, he had been at Morgan Stanley, he taught me a lot about spreadsheets. He's really good at this, and he's not a programmer. And he showed me this model he did for a business and had almost 40 worksheets. And I noticed also, some worksheets are only using one cell. Why? Because if he calls that cell, say, the interest rate or risk-free interest rate or something, it's the name of the worksheet, he doesn't care about the bank A1 and all the other formulas. He can read the formulas. Most people don't do that. He used spreadsheets so much that he basically discovered principles of good programming practices. He even told me, oh yeah, at some point I wanted to learn VBA, but it was kind of deterrent. You have to become a software engineer too. So actually it was one of the inspirations. I talk about the data abstractions is really deficient. Functional abstraction, composition is not there. But this is my favorite because people don't talk about this, and I think it's the major cause of problems. I say that the only object you really have to work with to create a model are the worksheets themselves, and then you just put stuff inside this grid. But from a model perspective, it's your array. But that's also a basic element of the UI. It's the foundation of the presentation. So you have a paradigm here where the model and the view are inextricably tangled, okay? And in fact, I'm going to show you, people noticed that at some point and they tried to break away. It didn't happen, also bad luck. So this entanglement of the model and the view caused a lot of problems. In fact, many of the other people say, oh, when I need to rearrange it, they are not flexible. If I need to merge spreadsheets, you don't have the ability to abstract that object array and you just program something. Let me, oh my God, I cannot go to my desktop. I wanted to show you, I feel crippled because all my icons are gone. I wanted to show you a model that I built for refinancing houses. And there is clearly, you see the asymmetry of like my mortgage, my current mortgage, and the new mortgage. And that could totally be abstracted into a functional object in itself. But you can't do that. So you have to copy and paste, duplicate code, rearrange stuff. It's very hard. I was talking there are actually more, but three notable partial exceptions. Numbers, this spreadsheet, I think was in the Apple, I don't remember. They actually separated the model from the view. The one that did it best was Javelin. And Javelin actually got a lot of traction. It was become very used and prevalent in the financial industry. And a very clean separation of model view. Look at, not just this comment from Wikipedia. I found a lot of people raving about Javelin. I never used it, but look at the date, 2011, and their interface was still like this. What happened to Javelin is that they were about to go IPO for a very good valuation just days before the market crash of 1987. The one of the savings and loan. I was not in America. And that critical. They didn't go IPO, then they were short of money, then a company acquired them, and then another company, Oracle, acquired the company many years later, about 2011. That had acquired them, and Oracle killed the product. And many people think that was a loss. There was still a lot of Javelin users. Javelin was the basis of many ideas that, in fact, look at the name there next. This was Steve Jobs considered this product superior. He wanted in the next computer. Or very good at doing pivot tables and other transformations. No, Excel 1 and we are stuck with the entanglement. Sorry, any questions? No, okay. So that's just repeating what I said before. How are we on time? How many more? Really? Okay. Because I don't want to be, I'm scared to death to go to the demo, particularly with the computer like this, but without the demo, I feel like you don't get your money's worth.
25 minutes.
Okay, good. So this is just me saying, okay, how people cope with these problems. There's no functional abstraction. Doesn't matter. I copy the same formula, even if it's this long, and replicate. They have all this interesting logic to adjust the references. And I consider intermediate Excel a user that really understands how to use the dollar signs to basically affect the translation of the cells when they copy and paste. Some people cope with macros and VBA to go beyond the lack of functional abstraction, etc. So the consequences are what then people see. Oh, they are error prone, cannot inspect and validate. Of course, it's A1 soup, easy to break without entanglement, not flexible, etc., etc. So, advocating is spreadsheets were not designed by people who knew about programming, language design, and implementation, which were already there at the time. It's a pity. So they should support product types, some types, and I will argue one of the reasons they're hard to validate is you cannot say, okay, these cells have a date or these cells have a string. What happened there is that Microsoft is always afraid of doing that because they say, oh, then people try to do something in this area or they get stressed out. Let's just then be able to plop everything and then they see, okay, pound value. It's funny, when there is a type error, it's always like pound value. And in very few cases, pound error. And I know all this shit because I implemented 140 functions of them. And they were not perfectly orthogonal, but pound value is the typical error for a type error. In our project, we actually have a pound type when the type checker fails, because we actually generalize Excel. So we try to be compatible, but give you the way out of it. Sorry? Okay. A functional abstraction, of course, I think you should come not a surprise to you. Let's just allow people to write their Lambda expressions, except how you don't scare people with that. We believe the key is like basically kind of UI with example that drives them by the hand. I frankly don't think it's a horrible idea for people to understand x minus x1 square plus y minus y square, take the square root, and now they finally have a distant function, right? Okay, so let's aim higher. Why you have to try to be just like Excel? Well, so how we do this? There's actually a very easy way, which I think most people here will advocate it. I don't follow it. Say, well, you know, everything you want to do, you do, and you do well, and even better in Haskell. So how about you just build a visual programming environment for Haskell? It probably is being done already. I actually don't know much about what's in the community, or for other programming languages. And actually, I heard that this is being done. It's becoming popular now, I think, for a reason. And well, in particular with lazy functional languages, this works very well. You know, you can do it also with eager one. It just depends how you do the evaluation loop, etc. My question is, what about adoption? I think that we basically built a better visual environment for a programming language, but that programming language is kind of like a bit of a deterrent for people. Have you seen this meme? Because I saw the meme, but I searched it on Google and couldn't find it. I came Haskell today, I has the dumps, and it was a cat. Nobody has seen the meme? I guess somebody, I remember I was a boomer when I saw this one. It was very funny. So maybe it was made by a guy and there, maybe it didn't become popular, but it's true. I actually saw that, and I didn't invent it, okay? I was looking at presentations about that. The guy say, let's be mainstream. I actually go, I went to the website, say one factor is that we make things artificially hard to learn, sometimes with a seemingly pathological glee. The emphasis is mine. I don't know if that's the case. I'm gonna come clean here, okay? Don't go hard on me. I am not academic, although I was teaching compiler constructions at some time, but not with PhD. I decided to get into functional programming not long ago, because of course I knew the affinity with this. This idea has been in my mind for a long time, because in 1989, not me, I was a professor at my university, had this idea, say, let's give something new to the students to do. Instead of this typical imperative language in the compiler course, let's do something that is a little bit more like this, but also has some flavor of imperative. So he came up with the idea, let's have a language where the variables take as variable formulas. And as I was working with this, I realized, this is a fork to specify spreadsheets, which is kind of like the opposite when Simon Peyton Jones look at the spreadsheets, they're functional. I was looking at the functional with the assignment to the variable, especially say, oh, this is like a spreadsheet. It's basically the two sides of the same coin. So I started to think about it. This can be an interesting paradigm, except I went the wrong way. Working at home, I was not doing this at work. I started trying to generalize it with object-oriented features. A product was called the object kernel. At some point, I had a lot of code there. But when I started rediscovering the functional programming, because actually I got interested in, I had a talk about FP in 1989, and I was interested when I learned, but I had just too much on my plate. So I decided, let me get into functional programming more and more. Particularly, I had done this spreadsheet engine at Bloomberg. After the people laughed at me, to me it was so obvious that they needed a spreadsheet engine. And I realized how ignorant I am. So I shouldn't be in this conference, okay? Really. I'm learning about category theory now. I'm learning about monads, I'm learning about all this stuff. But if the creator of them was a lot smarter than me says this, that makes me think. And he's not the only one. I saw also a presentation from Gilab Rasha, where he's saying, you know, they make things more complicated. So I am not a judge because I am a beginner, I'm a newbie. But if I see smart people saying we create too much of an impedance factor for the common layman out there to get into functional programming, maybe you should think about it. I didn't know about these guys. In fact, you see my slogan, say functional programming for everyone. That really it's been my slogan for the company since I started in 2010. I want to make functional programming accessible to people. Smart people, the intermediate guy in Excel, can do this. I am convinced about it, and I say it's actually an operating hypothesis. So our approach with a product called ZenSheet is push the envelope in generalizing spreadsheet. We actually start analyzing, okay, how is Excel as a programming paradigm? Unitype, first of all. These grids, can we unify the grid with a bidimensional array? Turns out we can. But that horrible A1 notation, yes, you can preserve it. But we support it only for bidimensional arrays of lazy variants. That way when people go already to the point where they do more strict data typing, etc., they don't need to do that. And we actually don't want them to program it in bidimensional array. You have a simple variable, don't do like Peter needed to create a worksheet for the risk-free, right? Just with the main, you say, I'm going to create a variable named the risk-free factor, and then you put it in the formulas. That's the basic, that's 50% of the gain just comes from being able to name the things the way that you think about them in your mind. And people in finance like that. They can read the formulas. They love it when they see it, okay? So we try to unify the, I would say especially about the pre-SQL Excel, unify them and generalize it with what we know about programming language design. And try to have a way that you can actually transform from the old to the new. In fact, some things can be done automatically. Every time you see a lot of formulas referring to a cell like a dollar column, dollar row, you know that that's a single variable. You know what I mean by simple variable? That's not a vector, that's not an array, dimensional array, that's a variable, and maybe should have a name. So the upside, and I say operating hypothesis because we are actually studying, we're going to run some trial with people who are, obviously there is an education factor here because people tend to find easy what they learn first, right? So I'm thinking about going to the high schools and do like a control trial. Teach some math with Excel, ZenSheet, see who actually becomes more productive and do some quantitative modeling. I'm trying to convince schools to do this. Of course, it's not easy, okay? But that's our operating hypothesis, that we are conducive to a smoother learning curve. There are technical challenges actually from the programming language perspective. Is there a pointer? When you see, if you represent the formulas, that like program-like symbol means it's a formula assignment. May put A8 times B8 on W is the name of the worksheet, bang, C8. When you do that, what is A8? Well, that's notice. The right-hand side of the assigned formula is what you type in the cell. And this exists, right? That's the moment the user types on the interface. And we are trying to make possible to automate that inside the spreadsheet itself, not going outside to VBA. But A8 means, it's a cell in the same worksheet. So it's horrible because the coordinates, the worksheet is implicit. Actually, that's relevant. Because if the worksheet is explicit there, when you copy and paste the formula to another worksheet, the worksheet carries out. If not, it gets translated to the other worksheet. Do you understand what I'm saying? Okay? So you can copy this formula to another worksheet. If the worksheet is not explicit, it's similar to having the dollar for the coordinates. If the worksheet is explicit, then it's tied to the worksheet. But if it's not, it translates to the other worksheet. The programming language, you have the dynamic chain, the static link, and the dynamic link, right? Here because we support unfettered data composition, we kind of need to know the closest bidimensional array that the formula is based on, because we need to infer to what worksheet is referring to. That, if you translate to array notation, will be something like this, and notice the W, it's implicit, right? But clearly, this is what we want to get away from, right? People can learn little by little. Okay, now I have records. What we were doing there was really the portfolio. Sorry for many examples in finance. Portfolio position sub 8 is, say, Google, okay? I have an array of positions, Google, Microsoft, Oracle, Amazon, hopefully, say that's my portfolio. A position survey could be Microsoft, so the value of my position in Microsoft is the price of Microsoft times the quantity, the number of shares of Microsoft I have in my portfolio. And the other formula could be something like the speed in kph, kilometers per hour, is my conversion from, and to notice the double dollar, like I said, because this is just a number. The conversion from miles to kilometers multiplied by the miles per hour. And at that point, by the way, we can do even a step better. And in fact, we have implicit vectorization transformations, which are not implemented yet, but are in plan. Yes, I was talking before about CUDA. We have 2 goals and no more than 2 goals with this. Like they say, you have to have a clear positioning. We want ZenSheet to be the tool of choice, again, I'll say like the intermediate advanced quantitative modeler guy. These guys do a lot of array processing. People who do kind of machine learning, people who do quantitative simulations, etc. So we want to have vectorization, implicit vectorization. So basically, now this can read like a vector operation. The value of the positions and the price of the positions times the quantity. How much time we have? 15?
13.
13? Okay, let me. Okay, so you know this can go fast. Basically, this is like have a bunch of basic types. You have a little more than that. We recently moved from having only one-dimensional array because of the reason having the vector processing very efficient. Decided, although makes implementation considerably harder, that the dimensionality, not the size of, but the dimensionality of the array is part of the type system. Okay, so our type constructor is array n comma t, array of n dimensions of type t. Product type, some types to be implemented because we are actually looking at OCaml and other languages. We care a lot about the pattern matching because that's something that makes programming very powerful. We definitely have functions of first-class cities, and I hope to show that. So I'm pretty sure there are some bugs there. And by the way, I have a disclaimer. This can easily crash anytime. It's experimental work. Gradual typing, you know what gradual typing means, right? Why gradual typing? All these choices sometimes written by the object we start with. Excel is unitype. Let's not throw that away so people can start. We can even read, in principle, an Excel worksheet and then start like help the user transform it and even automate some of the transformation. And we have a lazy variables. That's the essence of making it reactive. I'm not gonna, of course, only time to specify the language. Even we haven't specified the language. And we found stuff recently, that's like 3 months ago that, we should have thought about something better. If you have, the A is of type array of 2 dimensions, that the comma there means takes 2 in this. By dimension array of type T, and I is of type int, and J is of type int. And of course, this, you guys do the logic, you write with the user bar, your nice logic notation for the theorem prover, right? That's what people use. How many have used cock? How many have used cock? No, I don't believe it. I didn't get a single. You have not used cock? No? Okay. I'm surprised. It's very popular in, at Yale, in Princeton, where they are into the formal verification. And I actually happen to be lucky because I moved between New Jersey and Connecticut, so I actually connected with these people. Professor Appel, who worked on the ML. You mentioned standard ML, right? He worked on that. And Professor Zhong Shao has the formal verification. And those are the people that make me feel very humble and very ashamed of myself because they know so much. So I did actually a little bit of Coq, and I was tempted to say, let's try to specify the language in Coq. That alone will take me like a chunk of my lifetime. So I just do it my more intuitive way. So these are they're type inference rules, and we do have type inference, okay? I was talking about unification. To me, the most beautiful, but I kind of already gave it away, the most beautiful unified result of this work, if I want to say, a worksheet is a 2-dimensional array of lazy variants. It's a 2-dimensional because they are tied to the presentation grid, but it's 2-dimensional. Potentially unbounded. It's variants because the cells are not typed, but those are your mutable. And they're lazy because they are, in principle, they are all reactive. Okay, so It should be possible to assign functions to variables. We do pass functions as argument. So yeah, it's the first time I have implemented actually 5 or 6 between interpreters and compilers in my life. Most of them simple, yes, but like the calculation engine of the Bloomberg terminal, that was nothing but it was like over 50,000 lines of C++ code. We have the commonly used higher order function map, and in our Lambda test, we actually redefine this with the language itself adding a Z. So we prove that filter Z, it's equivalent to filter fmap Z, except we prove with the exhaustive testing. Okay, enough. So we're going to go to the demo. We have 10 minutes for the demo or less?
A bit less.
Oh, Jesus. Okay. So let me try. Can easily make a fool of myself here. Start the server. And start the client. Here's the full test suite. To me, it's like the breathing test. 5,226, yes, that's it. So the client, the server is working. We pass all the tests, the ticker, and socket to WebSocket converter. Now, where is sim? Okay, let me start this. Studio. I'm sure I'm going to make mistakes because I'm nervous, and actually I don't use it very much. I double in the code. And best way I'd save, where are they? See a browser? Okay, here it is. You can read that, yeah. var, it means variant p assigned 2.0. Lazy var x is 8.0. Notice the assignment with equal, colon equal, and then I put it in quote. That's like the quote in Lisp. I can also do the dot, like prolog sign, just happen to like that, and not put the quotes. Now, that lazy-fied transformation is not as simple as we just put the entire right-hand side on quotes. If the right-hand side is an array or bidimensional array, we go deeper. We quote the elements. Now I say, well, Enzo, what if I don't want an array of lazy something, but I want an array of lazy arrays, an array where the lazy elements are defined by formulas that return an array? Yes, you can. You can do all the combinations of laziness with anything in this language. The only problem is sometimes you have to put quotes. But when you specify a worksheet, it's very convenient that we go to the elements of the array, because then I can just write a single variable, put the column, the prolog sign, and then put all the formulas in an array. When we serialize worksheets, that's very useful. And see here also lazy var y, we put everything in quote. I did it down on purpose so you can see the equivalence, okay? So this is equivalent to this. Just to make quick. Some people might not like that, but that's what came natural from the definition. If I run, that was demo 0? Yeah. If I run demo 0, and this is what we're building now, and actually already loaded it. Here are the variables of the model, and I can add them to the view. I'm going to put all of them here. And here I'm going to put only P just to show that the complete separation is the same variable. I just have perfect flexibility. The view is just a set of elements of your model that you want to visualize. So, okay. This doesn't seem much interesting, right? But remember, those were lazy. What if I add here, I add some noise? What? Okay, because that uniform doesn't uniform. There you go. So now x changes and y that depends on x changes. Now you might have noticed these functions this is a double. Why you declare everything variant? Because it'll save me time in the presentation. Because now we're going to do something cool. Instead of x being just this 8 plus uniform, we're actually going to leave that way. And y has the p times log of x. We're going to, sorry, that's y. Yeah, we're going to change the definition of p to be a lambda. And this will cause a type error, of course. And so we're going to do that as take an x, and we're going to return the ln of x plus 1, let's say. Boom. And now I have an error here because this is trying to multiply a lambda by, I mean, we could define a semantic for that, but for us it's not, this is not going to work. But what I can do now is apply p to x. Done. Okay? So that's why I define if it's variant. Yes, you could have declared this with the proper type. And by the way, you notice how succinct that notation is that I can, in this, I was thinking about didactic purposes, because I did a lot of teaching at university. It's nice that you can now say lambda calculus, but close it lambda x comma y, and I'm sorry that we don't I mean, we actually, I have proofs where we clarify things, but so far I'm convinced with Gilles Baccia that RET helps people think, but I could be wrong again. I'm a newbie. I was saying that you can just put the names of the arguments with no type. It's optional there. If you don't put a type, it's assumed variant. If you don't put a type for the return of the function, it's assumed variant. Okay? Actually, did you notice that it was translated? Because, of course, we parse it, we build the abstract syntax tree, and then if we want, we could have rules to shrink this. And then you want to say, oh, but I want to show it like the user type, and then we need to remember information, which is always a bit messy, but you can do it. But did you see the transformation? It's actually, I didn't write var x returns y, I just put x there. But that's what it means. Yes, I'm living in a unitype world, but imagine I will have to write this entirely instead. Now, if I'm doing a simulation for a financial system, I do want to use the strict typing to help me not make errors. I read once that it's estimated that the loss of economic value that stem from errors in spreadsheets, it's already well over $1 billion. Like millions of dollars are lost every year for loss of spreadsheet. Notice, by the way, I move here, and this is P is the lambda, and I can change it. We have only 2 minutes left? 2 minutes. Wow, I nailed it. Okay, we're not going to have time for the Monte Carlo simulation. I'm going to jump to the last thing I had. I knew it's very tight to that. So I had a demo. Let me just run through the demos visually. I have a function dice that generates a dice, numbers between 1 and 6. And this one, notice, you actually cannot notice because it's cut outside. You see the colon, and I know that's people think about list concatenation. That means for us infer the type, okay? And we can put a name inside the columns, and the inference of the type will be unified with that name. And we have here, that will be an array of arrays. This one will be also an array of arrays, and they don't have to have the same, because it's not the same thing as a bidimensional array. Then the demo 2 was the same thing, but I was generating here the rows. So with this formula recursive that basically constructed. But the beauty was, how many minutes I have? 1? 1. Shall we go for broke? You think we can? Let's see if we can do this. Where is my client? Run. Because when you do it, I mean, I could load the final product, but if you do it live, it's more impressive. Actually, I should have. Do you mind if I go 1 minute off?
No, I think we can go 1 minute.
Okay. I don't know if did I close the browser? You know, I have like a keyhole on the real Windows of this computer. Where is Chrome? Okay. So that's actually good. So ZS for ZenSheet Studio. Okay, there are my right. So if I do the drag and drop, create a view. Dice I don't need. D row I'm going to need. Let's do the row here because we're going to change that. And wow, you're going to fit anything here, but it's okay. So this was fitting all in the screen, okay? I size it from my screen. You see the dice is there ticking, right? Now let's try the following. We're going to change this function, and we're going to put here a filter. Say, no, before, let me define a function that gives you the odd. So I'm going to type it here because I'm fast. So a function odd is, I type it right, is lambda of takes an n, and actually I want to say that returns a bool. It's a criteria, and the expression is if no, the expression is simple. It's n modulo. You did something similar to this. I just realized that I'll actually add this example. I hope I did that right. I call the function for then. I need to remember that. Okay, now I'm going to use here. Let's use the filter, the built-in filter. If I made a typing error. For n applied to this sequence. So help me God. All right. Do you see that? So of course it's random. Sometimes we get more odd numbers, sometimes we get less. I had also Monte Carlo simulation where you run 16 uniforms and then we do the sum and divide by the size. So you know that by the theorem, central limit theorem, that becomes, approximates a normal curve. And I take the logarithm of that, we paint it both in the same scale, and then you see the shift, etc. We won't have time for that, and so thank you very much. Okay.
Thank you.
Oh, the question, sorry.
I think we'll have time for one question.
And while you prepare the
Okay.
question. Please don't be afraid to ask questions. If I
So-
can give the answer, I will. I want people on my team. All these people who work with me, some of them abroad, and from my university in Latin America. I'm Italian, but I study computer science in Latin America. And this is the campus, beautiful place. All right. In case you don't have questions, because this was probably the easiest presentation in the entire conference. Okay, I felt humbled by the level of the presentations. You know, I love your presentation very much and the keynote. And I told my neighbor for the first time I got to see source code of KRC because I was always curious about this Kent recursive calculator. It's a great name. And I didn't know it actually came after Sazzle and the other. Many years ago, I read a book about a language called Poly. They also come from the I forgot the name of the guy. That book was one of the inspired me to think about other parts, because actually they are a little bit functional, they're very dynamic. There is some of Poly here. All right, thank you.
Okay, thank you once again.
Sorry for going over.